Hello students. This video will be a total class of quadrilaterals with some of the numericals. So I'm starting from new only. So we know that quadrilaterals are those shapes. These are those shapes that is made with four straight lines or line segment, you can better say. And the eligibility is that the condition is that it has to be a closed shape. It cannot be something like this. It cannot be like that. So quadrilaterals are those shapes which is made of four line segments. Okay, what are those four? This is 1, 2, 3 and 4. So there are four line segments in a quadrilateral. Now if this is a quadrilateral, so we can also say that this kind of shape is also quadrilateral. Why? Because it is having four straight line segments. Along with four line segments, it has four edges at the corners, as well as it has four angles at the corners. So in a quadrilateral we have four edges and four corners. Now talking about quadrilaterals, what are the types of quadrilateral generally we see? We can see some quadrilaterals which are called square. We also have something which is called a rectangle. So a square is something where all of these sides are of same length, whereas in a rectangle opposite sides are same. Along with that, you can notice that the angles in a square are same, whereas in a rectangle also these angles are same. Now if we talk about more quadrilaterals, then here comes something which is called a rhombus. A rhombus is something which is nothing but a square tilted in both of the sides. So in that case, all the sides are same, but all the angles are not same, and the angles are not 90 degrees. So these angles are not same, but you can see that the opposite angles are same, means this one is same as this one, whereas this one is same as this one. Similarly, we have something which is called parallelogram. A parallelogram is something like a rectangle, but the angles are not 90 degrees. In this case also, the opposite angles are same and the opposite sides are same. Then we have something which is called a trapezoid. A trapezoid is something where the two sides are parallel, but none of the sides are same and none of the angles are same also. Now, like in case of trapezoid, the angles we cannot say anything about it. Maybe two angles are same but others are different, but all of the angles will not be same. And lastly, we have something which is called a trapezium. There are some controversies regarding the definition of trapezoid and trapezium, but with the latest convention, most of the people believe that if we have some quadrilaterals where none of the sides are same or parallel and none of the angles are same, then they are called trapezium. Now these are the quadrilaterals. Let us talk about the properties of these quadrilaterals. If we talk about a rectangle, then we know that rectangle has 4 edges and 4 corners, that means, and 4 angles. All of these angles are 90 degree in value. So all of the angles are 90 degree in value. So that means the total angle is nothing but 90 into 4, that is 360 degree. Okay, so in case of a rectangle, all of the sides are of 90 degree and the total angle is 360 degree. If we take a rectangle and if we draw a straight line between two corners, these straight lines are called diagonals. So these are called diagonals. These are called diagonals. If we take a look here in the diagonals, we can see that there is a common point, that is an intersecting point, and also we can see that this intersecting point divides this diagonal into two equal parts and this diagonal also into two equal parts. So if I give some name A, B, C, D and O, then OA will be equal to OC. If we talk about angles, we know that all of the angles are 90 degree. That means A angle, B angle, C angle and D angle, these angles are 90 degree. Now if we talk about this angle ODC, that means this one, and if we talk about this one OCD, from the figure we can see they are same as well, and these are also similar to OAB and ABO angle also. So these are something that looking at the figure we can estimate. Now talking to some angles, we have learned that any kind of quadrilaterals are having 4 angles. So if these are 4 angles, so the principle is that quadrilaterals, if we just add all the angles A, B, C and D, so A plus B plus C plus D, if we talk about all the angles, the result will be 360 degree. So the sum of all 4 angles in a quadrilateral is always 360 degree. Similarly, if we talk about triangle, in case of a triangle, the sum of all angle A, B, C, the sum of all angle will be 180 degree. Now, two things are there. One, the 4 angles of a quadrilateral adds up to 360, and in case of triangle it is 180. If we take how to correlate with these two together, if we take a paper, let's say I'm taking a paper like this, and this is a square paper, and I fold the paper in the halfway. So if I fold the paper halfway, that means this portion I am just folding it. So ultimately what I will get? I will get something like a triangle, right? So I'm using a highlighter to show the previous part. So this was the previous, let me use this. So this was the previous part, and now it has become a triangle. Now when it was a square, we know that all these angles are 90 degree, and they adds up to what? They adds up to 360 degrees. So A, B, C, D. So all the angles A plus B plus C plus D was 360 degree. If you flip this, what will happen? This will be 90. Now, one thing you see here, when this is a square and you have a diagonal AC, this straight line, then this straight line divides this angle also into two equal half. One is this part, another one is this part. That means you can see that this DAC or A angle, better say A angle, is equal to the sum of DAC, that means this angle, plus this angle BAC, right? And the total angle is 90 degree. Now if the diagonal separate, or you can say divide the angle into two equal parts, then each of this angle, that means DAC or BAC, will be 45 degrees, right? So if the total is 90, so this small one will be 45, right? And same way, in the similar way, this C was 90 and now this diagonal has splitted it, so the small one, this means this much, will be 45 degree again. So when you will flip the paper, this portion will not be there because you have flipped it and it has become a triangle now. So now you have angles, this small one, that is DAC, that is 45 degree. You have 90 degree, that means the angle D, and you have DCA, that is 45 degree again, and the total becomes 180 degree. So that's why it is matching with our previous assumption, right? Previously it was 360, but whenever we fold the paper in such a way so that the square has become a triangle, the sum of the angle has become now 180 degree. Okay, so this is a practical situation. Now talking about it, we have seen that how these angles are being formed, but it is very difficult to show this for pentagon or hexagon. Now we know that something with three sides are called triangle, right? Something is with four sides are called quadrilaterals. Okay, something with five sides is called pentagon, and something is with six sides are called hexagon. So you can see that for triangle, the sum of all angles are 180. For quadrilateral, sum of all angles 360. For pentagon, there are 5 angles and the sum of all angles 540. There are hexagon and the sum of all angles are 720. So the general formula, you can say that this is nothing but 180 into 1, or you can say that side minus 2, you can say, because triangle is 3 sides. So I am writing this here, that will be better. So the formula is 180 minus side, 180 into side minus 2. That is coming 180, because side is 3 here for triangle. Acha. Now quadrilateral, this will be 180 into 4 minus 2, because 4 sides are there, that's why it is 360. For pentagon, so this is a formula you can see, and that's why you don't have to find it for pentagon or hexagon, but you can do in the same way, and you can find even for decagon and more than that. Okay, for any polygon you can find using this formula. This will be 180 minus 5 minus 2, sorry, into 5 minus 2, that is 540. You have 180 into 6 minus 2, that is 720. Why 6? Because there are 6 sides. Okay, so this is the general formula. So you can find out what is the angle of any polygon, what is the sum of all angles in any polygon using this formula, 180 into side minus 2. Okay. Now let us look at some more information about it. So I am drawing here something which looks like this. Now we know this is a triangle and there is a straight line, right? For a triangle, the angle, summation of all the angles are 180 degrees. Let's say this is A, B, this is C angle, and this outside one is, let's say, X angle. Okay, so the inside portion is C and the outside portion is X. We know that A plus B plus C is equal to 180 degree. Now if you look here, you can see that it's a straight line. If you talk about from this portion to this portion, it's a straight line here to here, and C is a point between them. We know that for any point the angle of a straight line is 180 degree. So that means if we talk from here to here, this whole portion is nothing but your 180 degree. Okay, so I can write here C plus X is equal to 180 degree. Okay, so that means I can write C is equal to 180 minus X, right? So if I put this value here, what I will get? I will get A plus B plus 180 minus X is equal to 180. Okay. Now if we further simplify this, I am writing here. So if we further simplify this thing, what I will get? I will get A plus B is equal to X. So here I have one formula, okay, whereas it says that the inside portion, the inside angle of a triangle is equal to the outside portion right here. Okay, so this is an important one you might need for some calculations. Fine, you will be needing it. So the inside portion, sum of the inside portion of like sum of the angles which are in inside portion is sum of two inside angles is equal to the outside angle. Okay, now let us look at some mathematics like that. Let's say I have something this. Here we have an angle X, I don't know, this is let's say 40 degree, this is let's say your 120 degree, fine, and so this is not 120, let's say it's 100 degree, and let's say this is 20 degree or 10 degree. and you have to find out what is x. So we will use that thing, that all the sum of all of the angles inside any quadrilateral is equal to 360 degrees. So I can write x plus 40 plus 100 plus 10 should be equal to 360 degree. So from there I can get easily what should be this x angle. Okay, so I think I have to take some different values. Let's say this is 170 degree or something like that. In that case, this first portion will be like that, and we will get 220 degree. So I am writing x is equal to 360 minus 220, that will be 0, 4, 1. So sorry, so that means the x has to be 140 degree. Some this kind of maths can come. Now more practical situations are like this. Let's say you have something like this, and okay, so in that case, so you know that each of these angles are 90 degrees, so it's very easy to tell. So you have to take some different like parallelogram. Okay, so in case of parallelogram, if I have to find this angle x and nothing is given to you, okay, you have to find this x, and say one thing is given to you, that is this angle. Let's say it is given 100 degree. We know that the opposite sides, or you can say the opposite angles of a parallelogram is equal. So that means if this side is x, that side also will be x, because opposite angles are same in parallelogram. If the down portion one is 100, so this one has to be 100 as well. So now I can use that formula again, or that principle, that the sum of all of these angles is nothing but 360 degree. So I can get here again 2x plus 200 is equal to 360, and from that I can easily find out. I can just take 200 that side, I will get 160, and if I divide by 2 I will get 80 degree. So that means, so it's not visible, okay, 80 degree. So that means x is equal to 80 degree, means this angles will be 80 degree. So in case of parallelogram, one angle is enough for us to find out other angles. Okay. Achha. Let us talk about some more maths. Let's say we have a triangle, as I have shown you earlier, something like this, and we have a extension like this. Okay, now this angle is given here. So you can see that this is a let's say this is isoscale triangle. So this angle is 45 degree and nothing is given. You have to find this angle. So we know that if this is an isoscale triangle, that means two sides will be same. Okay. So in case of isoscale, two sides are same, so two angles of this common side will be same as well. So this is 45, that means this one has to be 45 also. And we can use that formula which we were talking about, that inside one, like if we talk about two inside angles, if we add them, we will get the external outside angle. So here I can write that this plus this will be equal to this outside one. Okay, So the outside angle, let's say C is the outside angle here, and this is A, B, D. So I can write that angle ACB is equal to angle CDB plus CBD. That means this will be 45 plus 45 is equal to 90 degree. Now you can say that in my figure it does not look like a 90 degree because it's not a perpendicular, but I have just taken these angles as my guess angles, so that's why it is not matching with the figure. If I would have taken this as 40-40, it would be nice, it would be nicer, right? So in that case the situation should be 80 degree. So this angle would be 80 degree in that case. So this is the way we have to do some numericals, and also something can come like this. Let's say we have some problems like this. Okay, now these are given x, or let's say this is given 90 degree, this is 80 degree, this is 100 degree, and this you have to find out. So in order to find out this x, I must find out this portion. Okay, so let's say the inside one is y and the outside one I have to find out. So I can write the equation as y plus 90 plus 80 plus 100, because all the inside angle will be added up to 360 degree. So from that we can find out y, and that would be our 360 minus 270. So that would be 90 degree as well. So if y is 90 degree, I know that x plus y, because this is a whole straight line, so this whole part has to be 180 degree. So your x will be 180 minus 90, that means 180 minus y, that is 90 degree. So first you have to find out the inside one, then you have to find the outside one. So this will be for today's class and this chapter. Nothing else we have to do. We have to just practice some of the maths. Then I will see you in the next class. Bye bye till then.